Hi, 7th graders. Today we're going to talk about reflections on the coordinate plane. So again, a reflection is a type of transformation that can happen with an object. And so a transformation is going to be some sort of change. So we have translations, reflections, rotations, and dilations that we can do. We focused on translations yesterday, and today we're going to focus on reflections. So a reflection is going to be a flip. A reflection flips a figure over a line of reflection in order to create a mirror image. Okay, so reflection, you think of, you see a reflection in a mirror, same kind of idea. And again, similarly to how I look at translation being a slide, I think of the FL in the word reflection and the FL in the word flips, and that helps me remember that a reflection flips. So each reflected point of the figure should be the same distance from the line of reflection, but on the opposite side. And so sometimes our line of reflection might be the x-axis or the y-axis, and other times it could be a different part of the coordinate plane as well. So what we're going to do is we're going to look at our coordinates for our pre-image, which is the original object, the original picture we have here, and then we're going to reflect it over and find the coordinates of our image. So I have W, X, and Y in my pre-image coordinates. W is at 2, 6, X is at 7, 4, and Y is at 2, 2. And so here it says reflect triangle WXY over the y-axis. So we need to know which one's the y-axis. So our y-axis is right here. So what I'm doing is I'm flipping from here over and reflecting it here. So I should have a mirror image on the other side. And so when we do that, each point is going to be the same units away from the y-axis. So W was 2 units away from the y-axis, and all I'm doing is flipping it over here. So it's still going to be 2 units away from the y-axis, but on the opposite side. So this is going to be W prime. Y prime is going to be down here. And then X was 7 units away. So X prime will be over here. I'm going to go ahead and connect these to form our triangle. And then we'll look at, it's not perfect, but I think you guys get it. We'll look at our ordered pairs for the image now. So W prime, we're at -2, 6. X prime is at -7, 4. And then Y prime is at -2, 2. So if we look at what happened to our X values, all right, I went from 2 to -2, 7 to -7, and 2 to -2. So the X values became the opposite. And then if I look at what happened to the Y values, the W was at 6 and the W prime was still at 6 as its Y coordinate. So the Y values stayed the same. So if we think about how to represent this algebraically, we're going to start with our XY, our original point. The arrow represents that I'm changing it. And so if I want to think about what I ended up with, I need to take the opposite of the X. So I'm going to write, it looks like -X, but remember this negative symbol can be read as opposite of. So I'm going to take the opposite of whatever X is, and then the Y value will stay the same. All right, we're going to do the same thing here with triangle DEF, but we're going to reflect it over the X-axis. So first we'll start with figuring out our pre-image points. So D is at 2, -2. E is 7, -7, and F is 2, -7. And now this one, we are reflecting over the x-axis. So our x-axis is this horizontal line here. So each point still needs to be the same distance from the x-axis, but on the opposite side. So D prime is 2 units away from the x-axis, so now it's going to be 2 units away from the x-axis up here. F is 7 units away from the x-axis, so F prime is there, and E is also 7 units. So there are my new coordinates, my new points, I should say. All right, so we've flipped triangle DEF now over the x-axis. And so now we're going to figure out our ordered pairs for D prime, E prime, and F prime for the image. So D is now at 2, 2, E is 7, 7, and F is 2, 7. So if I look at my x values here, my x values stayed the same. My y values, though, became the opposite. So when I'm reflecting over the x-axis, I'm starting with my original point xy, and what's going to happen is my x will stay the same, but then it'll be the opposite of the y coordinate. And again, remember, even though that looks like negative y, you read that as the opposite of. All right, so let's look at a couple more examples. Here it says use the reflection shown to complete each statement below. So give a verbal description of the transformation. So again, we want to figure out our pre-image over here to our image. So I started with this figure on the left, and I ended up with this figure on the right. So the first thing, if we were to just give a verbal description of what happened, I flipped that or reflected it. And in this case, I reflected it over that y-axis. And so if I want to give an algebraic representation, all right, I went from my starting point, xy, and remember, if we flip over our y-axis, our x values will become the opposite, and the y values will stay the same. So whichever axis you're flipping over is going to remain consistent. So I'm flipping over the y-axis, so my y values stayed the same. And if we think about the size of the figure, that stayed the same. All right, orientation of the figure, that changed. And the orientation of the vertices also changed. Number 4, Bella believes the graph shows a translation down, while Scott believes it shows a reflection over the x-axis. Who is correct? Explain. So here we have 2 rectangles, so they're both rectangles, they both look the same. It looks like it could be hard to distinguish between if it's a translation or a reflection. So then what you need to pay attention to are the vertices and how they're labeled. So if I had just translated this rectangle down, then up here should have been L prime, because that corresponds to this one, this vertex. So since it's O prime, then that means that we actually did a reflection, and so we're reflecting that over the x-axis. All right, we're going to stop there for our notes on reflections. Have a wonderful day.